Why?
I don't know, he was there the whole time.
And he was playing?
No, he was just watching people work out.
Oh, he's probably trying to see who's all there, and then he's probably gonna yell at me today. He's gonna be like, you need to be in the way. You're always talking back to me. Oh.
Why are you so loud?
Yeah. Okay, I will explain. Yesterday,
Yeah,
we were doing like stance.
Tara, are they okay? You find any mistakes?
We were doing like stance shuffles, and he's like, Stone, stop crossing your feet. And I literally wasn't crossing my feet. So I told him, I'm not crossing my feet. And then he's like, yes you are, I'm watching you. And I literally looked down, I'm like, I'm not crossing my feet. And then like a minute later, he goes, well, they were getting close to crossing. And I'm like, that's not crossing. You can't yell at me for crossing my feet when I wasn't crossing my feet. And then he had to talk to me.
Did you really say like you can't yell at me?
No, when he said they're getting close to crossing, I was just like, we'd be like, sometimes I feel as if like he was nice to me when he was trying to get me into the school, and then now he's not anymore. Because he knows I can't leave.
That's true.
Basically, yeah.
But I can.
That's how it works.
I could leave if I wanted.
We're in your 0.
You have to move though, wouldn't you?
No, there's like, you can get like,
And you can give us.
there's other ways. Yeah, you can. There's ways you can get past.
Is that how you got past it? Or here?
No, because I was
What level are you again?
I'm a sophomore.
You should say like you're getting bullied,
Yeah.
and then
What she basically does.
Or I can really move because they literally offered to let me move like that. Mason Holtman. Like his dad's like, I mean, there's a guy who you could stay here if you want. So, options are still open. Do it.
Just wait for me to graduate.
Nah, I can never do it. Why?
You miss us.
Yeah, I miss Miss Donkey too much.
You won't find a better math teacher.
That's true. That's true.
All right, so Becca, this is your number 12, right?
Thank you.
Can we do number 2?
Yeah. Yeah, that wasn't my exhaustive list, I just started. All right, so 4 divided by 2 is 2 squared is 4. But then we have to multiply here, so that's 16. Then negative 6 divided by 2 is 3 squared is 9.
Oh my goodness.
You found your mistakes.
Yep.
Oops. I'm gonna keep going now.
Yep.
What does that add up to be over there?
No wonder.
School.
64.
Is it?
I don't know.
I mean, that sounds right.
That's what I have.
I multiplied. It did not add. And it did not add to 64. It is 64.
Yes.
All right. So then we have to get that to be 1 over here. So we're going to divide everything by 64. And then when I divide this one by 64, 4 over 64 simplifies to be 1 over 6, or 16, right?
Yeah.
So
Yep. Yep. I understand now.
I got this sentence.
all right. So let's look at number 2 then. Circles. Garrett forgot about circles.
Yep.
This one is kind of a strange one because there's no constant term. So we don't have to move anything over. So, and the x squared doesn't have anything next to it. But I still have to do the b divided by 2 squared. So the negative 6 divided by 2 is 3 squared is 9. So that means I have to add it over here as well. Now x squared doesn't have anything with it, so that means the h value is just 0. So that's actually the equation of the circle that we want, where our h and k would be 0, 3, and then our r would be 3 because it's 3 squared. So I think circles now probably feel so easy compared to the ellipses because of we don't have to worry about the factoring out and like I don't know. And this one was even a little bit strange because again there was no constant term to begin with. So then again we'd start at 3 up here, and then we go out every direction 3, and then draw our circle, which kind of looks like an ellipse. So.
Awesome.
So what we're gonna do today, you guys, is we are gonna like just touch on the start of what we call hyperbola, which there's hyperboles in English. This is a hyperbola in math. Every time I try to type hyperbola in my like search bar, it kept trying to give me hyperboles. But so we're gonna learn a little bit of that today, just the basics of it. We're not gonna do any of the completing the square stuff with it. I just want you guys to get the shape down. And I'll probably even shorten the homework. The homework's only like 6 questions. Well, we'll see, 6 questions, but so hopefully a lighter-ish day.
Just a little example. He has not. He won't make it a light day. He probably has to have it.
Is chemistry hard?
I don't know. Other people do that. I guess like some things are.
I feel bad because people ask me for help in chemistry, and there's enough similarities with chemistry. I mean, I like chemistry because it was math. There's a lot of math in it, but I haven't taken chemistry since I was a sophomore in high school. I never took it in college or anything, and so like, I mean, I'm more than half my life ago I took chemistry, so I do not know. So I'm not a tutor for chemistry.
This hurts my brain.
Hurts your brain. The drawing.
Yeah. Oh, it's like the same.
It's a very similar equation, which is why you're going to be so glad you did a note card, because the similarities are like kind of ridiculous, like how close they are, but a note card will be key.
What's up?
I hate it because you know how I always do this?
Yeah.
Well, when I
Don't cross your legs.
Um,
Crossing your like
Yeah.
you didn't get that joke from this morning.
Yeah.
No.
Because she told us about this right now. You told us about it.
Oh. No.
It's okay, he's like, it's not there.
When I don't eat, like when I do that, my foot falls asleep. Because I was like, no.
I feel like you're a poster child for like why not to like
Not eat.
yeah.
How do you open this?
Here, you slide it.
Oh my gosh.
There's an arrow in the way.
Such a smart kid normally.
How much pieces
So
of
stone.
I don't care. Don't take them all. Stone like, it was like talking like with his mouth half shut. So like, he looks really different. And he looks sick. Like, you look sick.
I don't feel sick.
You don't feel sick?
No, I feel sick.
Yeah, you look kind of sick. Sorry.
I feel sick.
I am sick.
No, like, just
You
like.
don't look your healthiest.
Yeah. Yeah, kind of, yeah. He looks like, just like,
Oh, I agree.
It's just like that sometimes.
no, not for all
Sometimes we
people.
can't all wake up bushy-tailed and pretty every day. Okay. So
Sorry.
I know it really makes me sad. Okay, so you might wonder why we're graphing a line. Part of these lines are going to show up in our hyperbolas, and I keep on calling it a hyperbole after that. Hyperbolas. Now, with talking with, like, you know, I first time here teaching pre-calc, so I talked with Mr. Hatfield about kind of what he's done in the past. Now, he typically doesn't require us to be really, really specific about this piece of our hyperbolas, but we'll use it a little bit today just to think about it initially. So wanted to remind you guys of graphing lines. So the slope is 2/5. So this one would start at 0, 0. And then I go up 2/5. And then I can reverse that and down 2 back 5. There is our line. So there's lines in like kind of like their boundary lines, like our asymptotes that we talked about before. Those kind of show up here in our hyperbolas. So this would be like a boundary line. So I tried to like show this little graphic where it says figure 1 of where all these different shapes come from. So if you take 2 cones and kind of like put them on top of each other, so think of a 3-dimensional cone. If you slice the cone straight through, it's a circle. If you slice it at an angle, it would be an ellipse. And the hyperbola and parabolas we talked about before. We're going to talk more about them after break. But a hyperbola is if you go the long way through the cone vertically, it would make a hyperbola. It's basically like 2 parabolas like facing opposite directions. So that's what we have, like these images here for you guys. So trying to show you that. And what we're going to be drawing today is these hyperbolas, which is this like red line here. And again, these lines, these asymptotes that go diagonally, those are what we're going to kind of be maybe leaving out a little bit because those take a lot of extra time to draw in. But if you notice, there's a vertex, there's a focus, that all like repeats just like it does in our ellipses. So Becca pointed out like these equations are super similar to our ellipse equation, but there's enough similarities or maybe not enough similarities or differences that makes it really, really tough to remember the difference between them. And so, I mean, I'm gonna struggle like initially like trying to remember the difference until I get into the section because it's really, so I'm gonna make sure I check my notes and stuff, but there's so many similarities that this gets a little bit dicey. So what's the big difference you guys see?
That y and x.
So y and x switch, so like rather than having the a value be under like the bigger one, the y and x switch, and what's the other one? It's subtraction instead of addition. So that's another big difference between these two. Sorry, like a tickle in my throat. So the big difference between these two. And so we'll talk about what that means for us. Now, again, those slight differences are kind of just enough to be annoying. But at the same time, there's a lot of similarities that we'll be able to use. So the one on the left, the x squared is first. What that means for us is the hyperbola is going to go, oh, big line. They're going to go left and right instead. So since the x squared is first, our hyperbola is going to go left and right. So it's a horizontal shape. And then when the y squared is first, it's going to be vertical, so up and down. The good news is our center is still h and k. That doesn't change. And notice the h and k have those opposite signs. Now, I will tell you guys right now, when I was doing my homework, I did the answer key for our homework. And I was, when the h comes second, I was flipping my coordinates. So do you notice that? So h sometimes will come second in this case. So it's still h and k. Yeah?
Never mind. I was going to ask, how do you know? But it's just h is by the x, right?
Yeah, so h is still by the x, k is still by the y, but so sometimes it'll come second, and so we'll see that in a few of these.
Okay.
And at one point I felt like my graph was wrong, and then I checked it in decimals online, and I was like it was flipped because I hadn't noticed that. All right. So now again, the foci, the focus points, are still important. They're going to be like inside the hyperbolas. So they're going to be like within there. And we kind of find them the same way we did with ellipses. I actually wonder if it's exactly the same. Oh no, it's not. Of course it's not the same.
Of course.
Oh wait, no. Foci are the same, sorry.
Yeah.
Vertices are the same. It's okay. So they're okay. So the foci, it's always, you're adding the C value. And remember, C doesn't show up in our formula. We'll talk about the C down on the bottom here. So it's X plus or minus C. Yes, thank you. I just wanted to remember it was the first one, but yes, thank you. So H plus or minus C, and then the K stays the same, and then it's the opposite over here. Oops, no, H. The vertices, again, still go with A, just like they did with ellipses. So that's still the same. Oh. Now, rather than calling it a major axis and a minor axis, I don't know why they don't. The major axis is considered the transverse axis, which is the one that goes through it like the main way. So like it's going to be horizontal here, and this one's going to be vertical. And it's just the same way it was before, where it's just the K value. So it's going to be y equals K. Whereas this was X equals H. And then flipped over here. So it goes the opposite way. All right, so one of the new things is these lines that go through the graph. And again, these are the ones we're just gonna kind of sketch them in there. We're not gonna like make a big deal about them. That was probably what was taking me the longest when I was doing my homework key, and then like I said, I talked to Mr. Hatfield about it. The slope of the asymptote is basically like through the center, we're gonna kind of go up and over and kind of draw these like boundary lines. And the way the slope is figured out, on this one, the slope is gonna be plus or minus B over A. And the A and B are up on the top. And then this one's plus or minus A over B. Now basically the way to think about that, it's rise over run, it's the Y value over the X one, so whatever's underneath the Y value is going to go first. And then the A, B, and C relationship is the same as each other, but not the same as ellipses. So that makes it weird. Here, this is where it gets, it's A squared plus B squared rather than minus. So again, thank goodness for a note card. Oops.
Can I use some of that lotion?
Yeah. Yeah. When did we have it up?
Oh yeah,
We have it on our tray
We're
now.
passing it around. I think almost everyone in class used it. Not me though. And Frank. He's allergic
Yeah.
to citrus.
And then we were like, don't lick anyone. So if you notice, we only have 3 that we need to do here. We might not even need, like, once you guys feel like you have the hang of it. Only 3. Alright. So the y is first, and then we're subtracting the x. I might stop my video because it's already long.
Yeah, that's a good idea.